Now we're going to move into section 11.7. We're going to be talking about probabilities with multiple events happening at once or one after the next. Sometimes we see this stuff talked about in the context of the multiplication rule. We don't really use that notation in this book, but here it means kind of the same thing when we're looking at probabilities of things involving and, where in particular we have to pay close attention to whether those events have an effect on each other. We say two events are independent if one does not affect or change the probability of the other in any way, and we say two events are dependent if one does affect a change on another, given that it has occurred. And that leads to something else called conditional probability, but we're going to see that later on in the section. For now, let's just think of a couple of quick examples to get the idea here with this notation, where what we want to do is determine if the following events are dependent or independent, where the pairs we have are selecting a queen from a standard deck of 52 cards, not replacing it, then selecting a king from that same deck, tossing a coin and getting a head, then rolling a die and getting a 6, where it's a 6-sided die, and driving over 85 miles per hour and then getting into a car accident. Where, for these examples, what we want to do about this is think of whether or not they're connected in any meaningful way. For example, if we're thinking on that deck of cards, and the first one we draw is a queen, well, we take that queen out of there, there's a probability of this happening, 4 out of 52, and then we're not going to replace it, so just toss it away. Then think about what happens with the king. What we should understand here is because I threw that queen away, I took it out of the deck, there are only going to be 51 options left for the king. So, in the first case, because there are fewer options, in particular there are fewer for the second, the king, the events are dependent. If I want to be more specific about how I'm saying that, I would say that the drawing of the king depends on the drawing of the queen. Or even though the probability is still very close, well, it did change. For the second case, when we're talking about that coin flip and the dice roll, presuming that what we have here is not some weird magnetic die that causes 6 to be drawn closer to certain rolls or flips, and these are just regular old pieces of plastic and metal, or metal and metal, or whatever it is that you're flipping, they're normal because they don't affect each other. These events would be independent. There's nothing too complicated about this idea of dependence and independence, at least in this context. It's really just those things that happen. Does one make the other more or less likely? In this case, the answer to that question would be no. And for our next example, when we're looking at the car, some might say that as you drive faster, you get more cautious. For others, driving faster means that they're being less cautious. But even though we don't have numbers attached to it, presumably, driving faster changes the probability of getting into an accident. And whether you're can't think of a good race car driver off the top of my head right now. I don't know why I'm drawing a blank on that. But whether you're someone who does drive very well under pressure drives better when they're driving quickly, or you're someone who really doesn't like ever going above 60 miles per hour, your likelihood of getting in an accident would change the faster you go. So they are dependent. Even though there, we don't have that numerical relationship that we could think about, like in the first case, where drawing the one meant that you had less for the other. In this case, it's just sort of abstract, but hopefully it does make sense.